Students, now I am giving the notes of transpose of a matrix. That is, in that matrix, transpose of a matrix, we want to study some results and theorems. So I am giving in the first video that the next we can do some questions. So what is meant by transpose of a matrix? The matrix which is obtained by interchanging the rows and columns. Let's see, if A is a matrix, then if we interchange the rows and columns, we get transpose of that matrix. If A is a M by N matrix, then A transpose is transpose, that is A dash. It is denoted by A dash or A raised to T. Sometimes in some other books we can see that A raised to T. Capital letter T, but it will be written as small. So A transpose is N by M matrix. That is, if A is M by N, then the rows and columns are interchanged. Therefore, the order of A transpose is N by M. A transpose, that is A dash, is N by M matrix. Example, A equal to matrix 1, 2, 3. Next row 4, 5, 6. That is, order is 2 by 3. Then A transpose is, you interchange the rows and columns. That is, we change, either you can change the row as column. So when we get 1, then we get 1, 2, 3 and 4, 5, 6. Or you can change the columns as rows. That is 1, 4, 2, 5, 3, 6. That is 3 by 2. Then properties of transpose. A transpose whole transpose equal to A. That is, we can see that if you interchange the rows and columns one time, again you rechange it, we get A. So A transpose whole transpose equal to A. And Ka whole transpose equal to K into A transpose. That is, K is a scalar, K into A transpose. A plus B whole transpose equal to A transpose plus B transpose. If A and B are, here A and B are of same order. A into B whole transpose is equal to B transpose A transpose. And next portion is symmetric and skew symmetric matrices. A square matrix A is said to be symmetric if A transpose equal to A. And if A transpose is equal to negative A, we say that that square matrix A is skew symmetric. So just study this. Symmetric. If A is symmetric, A transpose equal to A. And if A is skew symmetric, then A transpose equal to negative A. In a skew symmetric matrix, this is very important note. In a skew symmetric matrix, all the diagonal elements are 0. All the diagonal elements are 0. We can expect this as objective type questions, or some matrices will be given, then write which is skew symmetric. If the diagonal elements are 0, then you can write that it is skew symmetric. So please try to understand that for symmetric and skew symmetric, the matrices should be square matrix. Okay, that is, number of rows and number of columns should be equal. Okay, then there are two theorems. The first theorem is, for any square matrix A with the real numbers, A plus A transpose is a symmetric matrix. A plus A transpose is a symmetric matrix, and A minus A transpose is a skew symmetric matrix. A plus A transpose is symmetric and A minus A transpose is a skew symmetric. There is a proof for that. That is, let we take A is a square matrix, it is given. Okay, then take B is equal to A plus A transpose. To make the proof easy, we can take that B equal to A plus A transpose. Then we want to prove B transpose equal to B. That is, we want to prove that A plus A transpose is symmetric. That is, please study this proof. Sometimes they will ask like that, prove that for a matrix A, prove that A plus A transpose is symmetric and A minus A transpose is skew symmetric. We can't use the counter examples. We should prove like this. So B transpose equal to A plus A transpose whole transpose. That's equal to A transpose plus A transpose whole transpose. Since A plus B whole transpose equal to N transpose plus B transpose, we know that A plus B whole transpose is A transpose plus B transpose. Therefore, here A transpose plus A transpose whole transpose. That's equal to A transpose plus, another result, A transpose whole transpose equal to A. So instead of A transpose whole transpose, here we can write A. That's equal to A plus A transpose, the commutative property. In matrices, A plus B equal to B plus A. So A transpose plus A can be written as A plus A transpose. That's equal to B. So B equal to A plus A transpose is symmetric. So first part is proved. Second one, to prove that A minus A transpose is skew symmetric. We want to prove that A minus A transpose is skew symmetric. To prove C transpose equal to minus C. We want to prove that C transpose equal to negative C, that is skew symmetric. So C equal to A minus A transpose, then C transpose equal to A minus A transpose whole transpose, that's equal to A transpose minus A transpose whole transpose. Okay, what is the result? Same result, that A plus B whole transpose equal to A transpose plus B transpose. That's equal to A transpose minus A transpose whole transpose is A. That's equal to, you can take minus outside, minus of A minus A transpose. That is negative C. So C is equal to A minus A transpose is skew symmetric because C transpose equal to negative C. Therefore, C is equal to A minus A transpose is skew symmetric. Then, theorem 2 is, any square matrix can be expressed as the sum of a symmetric and skew symmetric matrix. Sum of a symmetric and skew symmetric matrix. So this is an important question. Write the given matrix as the sum of symmetric and skew symmetric matrix. We can do the problem in next video. Any square matrix can be expressed as the sum of a symmetric and skew symmetric matrix. That is, how can we write it? A equal to half into A plus A transpose. A plus A transpose is symmetric, then its half is symmetric. Then another one is A minus A transpose by 2, or half of A minus A transpose. From first theorem we know that A minus A transpose is skew symmetric. Its half is also skew symmetric. If you expand this, half A plus half A transpose plus half A minus half A transpose, then you get A. That means this is matrix A can be expressed as the sum of two matrices, which are the half of A plus A transpose and half of A minus A transpose. There, half of A plus A transpose is symmetric. Why it is symmetric? A plus A transpose is symmetric. So into 1 by 2 is also, that is half into A plus A transpose is also symmetric. And half into A minus A transpose is skew symmetric. Then one more result we want to remember. A transpose whole inverse equal to A inverse whole transpose. So these are the results which we want to study in this portion of transpose of a matrix. Very easy and there are 2 or 3 important questions here, an MCQ question and 2 marks question and that 3 mark questions also. So please study this results and share this to your friends, and if you like the video, please like it, and if you are watching this channel for first time, please subscribe it. Thank you.